Good morning and welcome to our Ryegrass webinar. My name is Sally Green and I'm the Marketing Communications Lead here at Syngenta. And I'd like to introduce you first to Georgina Wood. She's our Field Technical Manager and Grassweed Specialist, and also Gill Colman, who's our Marketing Manager for Grassweeds. Georgie will be taking us through some slides today about ryegrass and touch on some points about application and best practice. Just a couple of points on housekeeping before we start. We are recording this webinar, so you can only see us as speakers. You won't be able to see each other. So therefore, you can submit questions using the Q&A function at the bottom of your Zoom screen. So thank you again for joining. Basis and Neuroso points will be detailed at the end. And I will hand over to Georgie.
Thanks, Sally. Okay, so this morning we're going to have a quick run through a few things about ryegrass. First of all, just kind of looking at ryegrass as a weed and understanding why it's becoming such a problem. Then looking at the power of integrated control to get on top of it and to prevent it becoming a further problem in future. Just thinking about the best timing for residual herbicides, where Defy fits alongside some of the new chemistry that's in the market this year. And then we'll have a go through some best application advice for the pre-em residual season ahead. And hopefully we'll have some time for a bit of a Q&A at the end. So in terms of understanding ryegrass, I think a lot of work was originally done with blackgrass, kind of understanding that, understanding germination patterns. And that's been really key in developing our strategies to get on top of what was, in certain areas of the country is the biggest weed problem that we have. So just to look at ryegrass very quickly, again, we do have in both species peaks in germination in the autumn, but then we do also have spring germination, which can be a bit of an issue, but those peaks generally sit with Italian ryegrass especially, predominantly in the autumn. In terms of where in the country ryegrass is found, it's quite widespread. And seed return is a real issue because it has the ability to produce so many seeds and so can very quickly build up a very large seed bank to become a problem. And that's why we need to look at many different factors to control it, to prevent that seed bank from building up and creating a problem, especially as we see more and more that there is resistance developing to our post-em herbicide options. So all of these other factors become much more important in getting on top of the problem. So there's some data here about resistance risk, or a schematic here about resistance risk, and all of the different factors which add up to creating that overall risk. So there's many different points in our growing systems that we can target to help to reduce that risk. And in terms of the blackgrass work that we've done, that's been a big part of what Syngenta have done, particularly at our Barton Innovation Centre. We've been looking at all of these different points in the growing system. And actually what we've found in the subsequent ryegrass work that we've done is that a lot of these factors are relevant for both grass weeds. So all of these different areas are areas that we can focus on to help us to get on top of the problem. Now, the first thing to think about in terms of that strategy is delaying autumn drilling. And one of the things that we've done at our Doncaster ryegrass site, this was done a couple of years ago now, but our trialist Andy sprayed off one of the plots to see how much spring germination we got. So we saw from the charts that in many seasons you can have spring germination. In this season, actually 99% of the germination was in the autumn. Now, where we do get spring germination, and that will be dependent on moisture levels and different seasons, those spring germinators actually return far less seed than the autumn germinators. So if we can delay drilling to reduce the number of autumn germinators we have within the crop, then that's a really powerful way to reducing that population that we have overall. Another way that we can reduce the population that we have within the crop is by choosing a competitive variety. And now we did a lot of this work alongside ADAS in the blackgrass space, looking at the competitive ability of hybrid barley to suppress the blackgrass that we have within the crop and enable us to reduce the amount of seed that's returned to the seed bank for subsequent years. And you can see from the chart that 2-row barleys are more competitive than winter wheat. 6 rows, conventional 6 rows, again, more competitive than 2-row conventional barleys. But the hybrid barley does seem to exert a much bigger competition pressure on the weeds. And by increasing the seed rate, you can have an even bigger effect. So we see hybrid barley as a really good competitive variety to choose in order to reduce that seed return. We took that one step further this year and have looked at the whole growing programme and to see how we can stack up those control measures and what we can deliver in terms of overall control by doing that. So this is a really high pressure situation. It was drilled on the 15th of September, which I've already said is not delaying drilling. So this was under really high pressure in this trial. And then if I just build the slide up, you can see we've got the conventional winter wheat varieties, conventional barleys, and then hybrid barleys in those different orange boxes. You can then see our herbicide programs. So in the blue box is where we did apply a Preem, and you can instantly see the massive effect that that's had on reducing the population. That was a Preem of Liberator plus Defy. Then in the orange boxes, we've applied a Preemergence of 2 litres of crystal. So overall, this is our early autumn season chemistry approach over those different areas of the trial. And then on top of that, in the spring, we've then used Axial Pro as a post-emergence option to deliver additional control. So if we then take a look at the results that we got from this work, the boxes here are quoting the percent control that we have. So if I just draw out some of the figures that we have there, first of all, if we look in the untreated areas, you can see that as a standalone factor in a completely untreated situation, on average, the hybrid barleys at 250 seeds are giving us 5% control in the suppression that they deliver of those heads of ryegrass. You can then see, if we look at a Preem situation, the average across all of these figures is around 65% control from that Preem. And this is, like I said, a really high pressure situation. Now, if we look at the hybrid barley in the Preem treated area and compare that to the 2-row conventional barleys, you can see that where we had originally 5% suppression from the hybrid barley, in a Preem treated situation, the benefit of that hybrid barley increases up to 18%. So we're kind of getting a synergism between the two factors, whereby if we're reducing the plant numbers by using our Preem chemistry, we're giving our hybrid barley more of a chance in the spring to exert that suppression and reduce the population of heads even further. So it's really great that those two things act together and deliver more. If we then look at the amount of control we're getting additionally from the crystal Preemergence, on average that's giving us an extra 6% control. And then on top of that, if we look at these figures here and compare those to these, we're getting an extra 20% control from the Axial Pro. Now, it's important to note that that's not to say that Axial Pro is only delivering 20% control, because if we look at it as a standalone factor, it's giving us 60 to 70% control. And as I said, this is a really challenging population, and when tested has got a level of resistance. So that additional 20% control is when we're stacking it on top of all of these different factors, even in a really challenging situation. So if we add all of those up together, in the best situations where we're using the hybrid barley, we're using our chemistry, we can deliver 98% control of ryegrass by stacking all of these things together. but one of those factors alone cannot deliver anything near to that level of control. So it's really important to stack everything together and have a complete approach in order to get on top of this problem weed. And now, of course, when we think about adding chemistry on top of our cultural controls, actually the application of chemistry can sometimes be a challenge, particularly in the autumn. This is some weather data. It's actually from Cambridgeshire, which is where I'm based, and shows the autumn weather conditions that we had this year, and shows just how challenging it was. Heavy rainfall and very consistent through October and into November. So a really challenging situation, A, for drilling, and B, for getting any pre-emergence chemistry on. I thought I'd look back to the last season where we had a more normal autumn, so not the previous year, but the one before that. And even then you can see that although the peaks in rainfall are lower and there are many days without rain, actually there is quite consistent rain and consistently high winds as well. So it can be a real challenge to get our pre-emergence chemistry on at the right time, and that's something that we recognise. And if we're thinking about our timing for chemistry, and we all recognise that getting something on pre-em is where we want to be aiming. So pre-emergence is ultimately our best timing, because we know that we've got the chemistry on and we know that we've delivered some protection for the crop. It's also best in terms of crop safety, because at the pre-emergence timing, we have that barrier of soil above the crop seed, which is protecting them from the chemistry that we're applying. If we get pushed into the peri-emergence timing, when that first leaf is just starting to come through the ground, that can be a challenge in terms of safety of many herbicides to the crop. And that's because if there is any damage to those emerging shoots, because there's so little plant material there, any damage can, in the worst cases, cause complete plant loss. As we move later into the post-emergence timing, when we're getting towards 2 to 3 leaves and up to the first tiller, actually they become less risky to the crop because there's more plant material there. And if we do cause any damage, the chances are we may lose 1 leaf, but the plant itself will survive because it's got more vigor at that timing. So it's really important to consider what our mixes are and when we're applying them, and consider the effect that that might have on the crop. Just a picture here to illustrate what we mean by that peri-emergence time, and you can see those tender shoots just emerging through the soil there, which you typically see as like a green haze across the field at that time. But we have to think about how that timing contrasts with the efficacy of our herbicides as well in terms of weed control. So where we see the peri-emergence timing being particularly risky for the crop, actually it's a timing when our herbicides can be really effective because the weeds are also very susceptible to the herbicides at that time. So there's a real balance to be achieved between getting good efficacy, and the colours there reflect the efficacy that we might have, and balancing that with any impact that we might have on the crop. As we move into the late post-emergence timing, we know that our residual herbicides will be less effective because they're less able to control weeds, which are also getting towards these timings. So just to summarise it, just to give an overall view, you can see the balance that needs to be struck between peri-em and post-em timings, between that crop safety risk and residual efficacy. And in order to do that, we should be thinking about the number of actives that we're putting in the tank, but also the rates of those and balancing that, perhaps using a 2-spray strategy if we have been pushed from pre-em into peri-em, so that we're not delivering one heavy hit to the crop at that peri-em time. And one of the reasons that we're targeting pre-em is because it's the safest time for us to apply those big stacks of chemistry. And we know that those big stacks of chemistry can be very effective for weed control. This is data from blackgrass, but illustrates really nicely how stacking up a number of active ingredients can increase the levels of control that we're able to get of those grass weeds. So clearly, where we've stacked many different actives together, we're delivering much more in terms of control with that strategy. And if we think about where Defy should fit within that strategy, we see that because we have a 5 litre rate of Defy at the pre-em timing, you can see in the first chart on the left that with that 5 litre rate delivered pre-em, we can get very high levels of control. If we're saving the Defy for the peri-emergence timing, because we are restricted then to a 3 litre rate, our control does drop off. And then if we look at the chart on the right-hand side, you can see that at the pre-emergence timing, there is that benefit in increasing the rate from 4 to 5 litres. So pre-emergence timing does deliver the best control because it enables to use those higher rates of chemistry. If we have a look at Defy alongside some of the new chemistry that we have in the market this year, first of all, just looking at Liberator as our base product, we can see that 3 litres of Defy is adding significantly over and above that Defy base. This is from a trial which was drilled in the same field as that integrated control field, so it was a really high pressure situation. Alternator Met and Octavian Met are some new products in the market which also contain metribuzin in addition to flufenicet and diflufenican. And again, we can see that that metribuzin from the straight Liberator product is adding to control. But then again, we can see a benefit of Defy in addition to both of those products. Another new product that we have on the market this year is Proclus, which is an aclonifen-based brand. And you can see again that I've averaged those two trials because the rates are the same here. And you can see Liberator plus Proclus delivering nearly 80% control, and actually Defy delivering around about the same. But when we add those together to have those 3 products together, again, Defy adds more than 10% of control in addition to that. So there's lots to think about this year in terms of pre-emergence herbicides and strategies and timing. And it's really good to plan ahead in terms of having a plan should things not go, not be possible at that pre-em timing, as we've already discussed. So if we then move on and have a quick look at some application work that's been done and kind of our overall advice, because application is a really important part of delivering our pre-em products. First of all, I think it's really important to consider what we're actually trying to do when we're delivering those residual herbicides. And if we think about different water volumes, our advice has consistently been for a number of years now that we should be aiming for 200 litres a hectare water volume to get the best result from our chemistry. And that's because we're actually targeting a very small volume of water and product as formulated as coming out of the sprayer over quite a large area. And just to put that into perspective, if we're looking at 100 litres a hectare water volume, that's actually just giving us 10 millilitres of spray solution per square metre of the field that we're applying it to. So that's just 2 teaspoons of liquid that we're applying over quite a large area. If we increase that to 200 litres a hectare, we're doubling the amount of spray solution that we're delivering. Even that is only 4 teaspoons of product over a metre squared. So again, this is a precision job and is something that we should really think about and make sure that we're doing to the best of our ability, taking into consideration the different factors that we can influence. And this is some really nice data, or is an image, and the data is to follow, of some work that we've done with a drone technology company. And it's looking at spraying different water volumes with a dye that can be viewed from the drone. So it gives us a really good visual image of what we've achieved in terms of delivering that product, which in this case is the dye, but it is representative of our herbicides and how we've actually delivered that to the surface. So if I reveal some of these squares, first of all, it's the green that we're seeing here that's actually showing us the dye on the surface. So this is where we can see our product and how well we've distributed that across the soil surface. And you can see that some plots are clearly better than others in terms of the amount of green that we see within them. So then if I reveal what they are, it's then very clear to see that those with more green are those with the 200 litre water volume. So we've got a range of different nozzles that we've used, but you can clearly see that those with 200 litres have much more green than those with the 100 litre rate. So again, that reinforces the message that we've been saying for quite some time now, that 200 litres really does help us to deliver product over the soil surface as well as we possibly can, and that does come through to efficacy. And we can see that with some of the trials work that we've done with blackgrass over the years. And this box and whisker diagram is over 400 trials put together and shows the consistency of that 200 litre water rate. So if we just walk through it, just talk you through it. So we've got the range here from the top to the bottom of the whiskers is the range of data that we have. Within the box, we have 50% of the data, and the lines represent the different averages. So we have the average here and the median here. And first of all, you can see that with the 50 litre water rate, which is in the blue, we have a really wide range of results from the trials that were included. And on average, our control levels were around 55%. If we increase to 100 litres a hectare, you can see that overall, the box and whisker is getting smaller and the box itself is getting much smaller too. So more consistency in our results. And also that average is getting towards 80%. But we can improve that further. And you can see that 200 litres in the red, our box is much tighter. So our results are much more consistent. And we're much more consistently delivering results that are getting towards that 90% control. And if you go up to 400 litres, you can see that actually there's not really a benefit over that 200 litre a hectare rate. So that's why our advice has been 200 litres a hectare and continues to be so. Overall, that 200 litres a hectare advice came alongside the low slow covered campaign, which we've run for a number of years now. And it's just a reminder really that getting the sprayer set up is actually a really important part of what we do, and delivering the chemistry in the best possible way is important for protecting the products that we have and protecting the environment, making sure that we deliver the product where we want to. So having a boom height of 50 centimetres, a forward speed less than 12 kilometres an hour, considering nozzle choice, and in the correct situations, choosing to use 90% drift reducing technology. And again, that 200 litres a hectare water volume also important. Some of you may have seen the Spray Assist app, which we've developed, which can help you to consider your application technique. It's based on your location and local weather data, and give some advice around nozzle choice and the timings that are appropriate in terms of the time of day when the weather is appropriate to spray. And that can be downloaded from the iOS App Store as well as the Android App Store. And if we think about spray distribution, this is something that I did to help me visualize what spray distribution means, because we often talk about coverage, but coverage can be delivered in different ways. Both of the cakes have 50% coverage of icing, but the distribution of that coverage is very different. And that's something that is important when we think about those drift reducing nozzles that we have. So low drift nozzles help to ensure the droplets land where we want them to, which is much more likely to give us a distribution of our coverage more like the cake on the right hand side. And if we just have a quick look back through Syngenta's Nozzle Legacy, you can see that over many years we've developed lots of different nozzles with increasing drift reducing capacity. We've just developed the 3D90 nozzle, which is the next step in application technology, and it's a great innovation which helps us to deliver efficacy without compromising. And if we just have a look at the nozzle there, it is a combined cap and nozzle in one. It has a 55-degree angle, which we've developed specifically based on lots of research that we've done at our Gellets Hill Research Centre, because it delivers the best in terms of coverage of the front and back of the target. So in a pre-em situation, that's any clods that we might have in the field. It's a pre-orifice nozzle. That's how we deliver the drift reducing capacity of the nozzle, which means it is suitable for use with pulse width modulation sprayers. And if we just have a look at the detail there, we've got the pre-orifice at the top here. We have the body that produces that 55-degree incline. And then the tip is something that clearly we've done lots of research into and is a part of the nozzle we often look at. And that helps to deliver a really good coefficient of variation in terms of droplet size, which means that we have consistency of that droplet size, even when we're using the nozzle at different heights. So in terms of where we are in the development of this nozzle, it's currently undergoing its assessment for the 90% categorization. And we are very much hoping that it will come through that and be available in September for use. If we just very quickly have a look at some of the data that we've got from using this nozzle, this is some work that we've done specifically in a ryegrass situation, using the 3D nozzle, which was a technology that we developed a little while ago, but didn't have the best delivery of drift reducing capacity. We've got the 3D90 here and the TTI, another 90% drift reducing nozzle. And we can see that 100 litres, the 3D90 is delivering better efficacy in terms of percent control than the other two nozzles, but actually 40% control is still relatively low. If we increase that water volume to 200 litres, so increase the size of the nozzle to an 0.05, you can see there's a big change in the efficacy that we're delivering. And again, the 3D90 nozzle coming out on top there. And you will have seen this figure quoted by my colleagues at Syngenta before, but actually how you apply the product can be up to 50% of the product's efficacy in the field. So it's really important to consider. We've got the products here delivering 50% of the control, but then timing, mechanical setups at tire pressures and things like that, boom height, etc., can deliver 20%. And then fine tuning, so our nozzle choice can actually be 10% of the difference. And again, just to reiterate, when applying pre-emergence chemistry, remember the low-slow covered messages. So that is all from me. Thank you very much. Hopefully we now have some questions.
Thank you, Georgie. One question that's come in is higher levels of control were demonstrated by combining the impact of competitive crops with herbicides. Will this reduce seed return and provide benefits in future crops?
Yes, definitely. So that's what we were assessing in those trials. So it was the heads that we had of ryegrass within that standing crop. And we see that the pre-emergence chemistry reduces the number of heads, but also by using those competitive varieties, we see a reduction in the number of heads. And particularly in the blackgrass work that we've done, we haven't done this in ryegrass, but we also saw that where we reduce the number of heads, we also, with the hybrid barley, were reducing the number of seeds per head that remained in the crop. So that further reduces the amount of seed return that we have for those future crops. So yes, those two factors together help us to, make steps forward in reducing the seed bank that we have.
Thank you. And a second question here, just before we need to wrap up. Were any trials carried out at an intermediate water volume, so looking more at the 150 litres per hectare rather than the 100 or 200?
Yes, we do have trials where we've used those intermediate water volumes as well. And we tend to see a curve, actually. So 150 litres is better than 100. So, you know, it is an improvement, and if that's the balance that you need between kind of using a higher water volume, but also being able to do the amount of work that you need to in a day, then 150 is definitely better than 100, but 200 is better than 150. So it's a curve really, and it is balancing that work rate with doing, you know, the best job you possibly can. And perhaps the situations where you need to think about, okay, well, this field has a particularly difficult grassweed population, and I know that I need to do the best I possibly can here. So perhaps targeting those fields with 200 litres, and those which have a lower weed burden, which you're more confident in being able to control, that's where you can maybe compromise and go down to the 150 litres.
Excellent, thank you. So all that's left for me to do then is to wrap up. Thank you, Georgie, for your presentation, and thank you for those questions that have come in. You can claim your BASIS and your OSO points via an email that will be sent out shortly. You'll be able to pop your details in there, and we'll pass those straight over to BASIS and your OSO to be added directly onto your accounts. So thank you again for joining us, and we hope to see you again soon.